So hi guys, I hope you all are doing well. So in today's welcome back to my channel. So in today's video, we are going to learn a very new, interesting, and the topic that you have never learned before or heard before. You may have heard it before, but this is a very new chapter and topic that we are going to learn in today's video. That is the very famous concept of trigonometry. So welcome back to my channel. This is our chapter 8 of class 10, chapter 8 of class 10 mathematics, that is Introduction to Trigonometry. There's a very beautiful quote that is given by J.F. Herbert, that is, there is perhaps nothing which so occupies the middle position of mathematics as trigonometry. So let's get started and learn the very new concept of trigonometry. It might find you thoda difficult in the starting, but as much as you practice it and get your concept clear, it will be a very easy chapter and topic for you to learn. And trigonometry, trust me, is always behind you. It would never um, it would never it would never happen that you do not apply trigonometry or you do not need trigonometry. In the case of, it might happen if you take bio, there is no need of trigonometry. But yeah, in general also, in physics also, you need to learn trigonometry. There is a certain application of trigonometry, and yeah. So let's get started with this chapter, that is Introduction to Trigonometry. So trigonometry is basically a concept that is related to right angle triangles basically. So what do we mean by right angle triangles? Angle triangles means that one angle of the triangle is at 90 degree. Okay. So let's say this is at 90 degree. Let's say this is a point A, B, C. So in triangle ABC, my angle B is 90 degree, and angle would be something else and angle A would be something else. Okay, but angle A plus angle C would be 90 degree because triangle, the summation of all angles of the triangles is equal to 180 degrees, and as we know that angle B is 90 degrees, so therefore angle A plus C is 90 degree. Okay, this is a very this is the basic thing that you need to keep in mind. Whenever we deal with trigonometry, we should know that there is a right angle triangle that is going to there, because trigonometry is totally based on the like trigonometry could not exist without the right angle triangles. Okay, the whole concept and whole thing of the trigonometry is based on angle triangle only. Okay, so okay, what is so there are certain applications in which we need to calculate the height, we need to calculate the angle, or we need to calculate the distance. Okay, so maybe if we take an example, let us say we are on the ground level. Okay, I am on the ground level. Let's say I am at a ground level. Okay, this is the ground level. Okay, in front of me there is a building, right? Let's say it is a very big building, maybe 21 story building, but we know that it is a 21 story building, but I do not know the length of the building. Okay, I do not know the height of the building. This is the height. This is the height of the building. Let's say it is denoted by h. But interesting thing is, here we know that if I know the angle of the building, maybe from this point. If I know the angle of the building from this point to the top of the building, okay. If I know this angle, let's say this angle is theta. And now, as the building is standing on the ground, you know that a building that is standing on the ground would make an angle of 90 degree. Okay. So let's say it is a angle triangle. And if I know this angle and I know this distance, let's say the point from where the angle is calculated till the height, let's say it is x. Now, if I know, now I have three unknown values over here. That is theta, x, and h, right? Theta, that is the angle, h, and x. If I know any two values of the between from any of these three values, then I can find the third value. That is the value that would be help us for anything. Okay, it might not help you for a class 10 as a class 10 student, but it might help you in the future. Okay. So if I know this angle and if I know the distance from the point to the building, then I can calculate the height of the building. I know that the building is 21-story building. Okay, I know the number of floors are 21, but I do not know the height of the building. Okay, so in that case, we can use this the concept of trigonometry. And as a fun fact, or maybe as an information, trigonometry has been used earlier also in the formation of Egypt. Well, like it is recorded that it was used in Egypt and Babylon, and also this is used in advanced methods for physical sciences and in astronomy also, to find the distances of stars and planets from the Earth. Okay, so earlier it used to be we used to use the concept of trigonometry. Okay, now we need to focus on the word trigonometry. So what do we mean by trigonometry? Okay, trigonometry is found by three sub words, that is tri, gono or gon, gon, or and metry. Okay, or metron. Okay, it is derived from Greek words, that is tri, gon, and metron. So you know that tri means three. Okay, tri means three. You know that gon means sides. Okay, we say polygons, right? Polygons, exactly. So gon means size and metron means measure. In fact, trigonometry. Therefore, trigonometry is the study of relationships between the sides and the angles of triangle. We saw that it is a relationship between the sides and the angles of the triangle. Okay. Okay, cool. So now let us take a right angle triangle. I would like to use red color over here to the triangle. Let's say I have a triangle A, B, C, that is right angled at angle B. Let's say this is the angle C, this is the angle A. Okay. Now, three things that you know need to understand is this- hmm. three things that you need to know is what are these sides called as. Okay. Uh, I'll just rename the triangle. Just a second. For a better understanding, I'll just rename the triangle as it is given in the textbook. So this is angle A, this is angle B, and this is angle C. Both are right angled at, sorry, the triangle is right angled at A. Hmm. Now, if I know that this is the angle A, yeah, sorry for the disturbance. So you need to focus on the things that are given. So what do we call these sides? Okay. So the side opposite to the right angle is called the hypotenuse. Okay, it is called as hypotenuse. You may have learned Pythagoras theorem, so you know that what is a hypotenuse. Okay. Now we are concerned with angle A. Okay. So the side opposite to the angle A, this is the side that is opposite to the angle A. Side opposite to angle A. And you know that this side, that is side AB, uh, AC is the hypotenuse and BC is the side opposite to angle A. And you know that now side AB is the adjacent side, adjacent side. So basically, what we need to learn in this chapter is we need to know the trigonometric ratios that are predefined, and we need to learn and use the application of those trigonometric ratios. Okay, I hope that is clear that AC is the hypotenuse, BC is the side opposite to angle A, and AB is adjacent side. Okay. Now, what if I redraw this triangle and just if I'm concerned with angle C, okay, if I'm concerned with angle C, so now for angle C, this is the hypotenuse only. That is not a problem. But the things that would differ is, so AC is the hypotenuse, then that is fixed. But now my side BC would be the adjacent side, and my side AB would be the side opposite to angle C. Okay. So now we shall learn the trigonometric ratios, and that you need to learn in the terms of adjacent and opposite sides only, because some now in this case you saw that for angle A, side of opposite to, so for angle A, BC is the side opposite to angle A, but for side angle C, BC is the adjacent side. So that is why, if you should not be mistaken, that is why you need to learn the trigonometric ratios using the sides only, using the wordings that I am going to use. Okay. Now for ये आइला ये क्या हो गया? Now for triangle ABC, right angled at B, and if I'm considering angle A, so therefore my trigonometric ratios are sine A, sine A is equal to sine A is equal to side opposite to the angle upon the hypotenuse. Okay, is that clear? So for sine A, side opposite to the triangle, that is BC, uh, side opposite to the angle BC, and the upon hypotenuse. ठीक है? For cos A, so basically sin A, cos A, tan A, whatever we are going to learn are the trigonometric ratios that we need to learn. ठीक है? Cos A is the adjacent side upon the hypotenuse. ठीक है? Cool. Okay. Uh, Here cos A means cos of A, whatever the angle of A is, let's say 90 degrees, 30 degrees, 30 degrees, 60 degrees, 45 degrees, 25 degrees. So cos A, that is here we are going to learn. So tan A is equal to the side opposite to the angle upon the adjacent side. Oh, I'm sorry. This is B. So therefore we can also write it as sin A upon tan A. ठीक है? Cool. Next up we have cosec A. Cosec A is hypotenuse upon the adjacent side. It can be also written as 1 upon cos A. Then, sorry, I've written it wrong. Cosec A is hypotenuse upon the opposite opposite side of the opposite of the side opposite to the angle, that is 1 upon sine A. Then next up we have sec A, that is hypotenuse upon the adjacent side, this AB, and can be also written as 1 upon cos A. And last but not the least we have cot A, that is the adjacent side upon the adjacent side, that was AB, upon the side opposite to the angle A, that can be also written as 1 upon tan A, and also be written as cos A upon sin A. So if you focus over here, we only need to learn the first three trigonometric ratios, that is sin A upon sin A, cos A, and tan A, because then other three ratios are the reciprocals of the first three ratios respectively. ठीक है? So in textbook, they are also given in the long form. Okay, sine of A is written by SINE. Okay, sine of angle A is side opposite to the angle A upon hypotenuse. Cosine of angle A is the side adjacent to angle A upon hypotenuse. Then tangent, in short, we write it as tan. Tangent of angle A is side opposite to angle A upon side adjacent to angle A. Then we write cosecant of angle A. Cosecant is, in short, is written as cosec. ठीक है? It is written as 1 upon sine of angle A is equal to hypotenuse upon side opposite to angle A. Then we have secant of A. In short, it is written as sec A. That is 1 upon cosine of angle A, that is hypotenuse upon side adjacent to angle A. And then we have cotangent of angle A, that is written as cot A in short. That is 1 upon tangent of angle A and side opposite to angle A. So therefore, they are abbreviated as sin A, cos A, tan A, cosec A, sec A, and cot A respectively. And you also need to focus on the thing that cosec is the reciprocal of sine, sec is the reciprocal of cos, and cot is the reciprocal of tangent. So therefore, if you learn the first three ratios, then we could easily derive the other three ratios respectively. Okay. So therefore, the trigonometric ratios of acute angle in the right triangle express the relationship between the angle and length of the side. So here we have got the angle also, that is angle A, and we have got the sides. Okay. So therefore, the trigonometric ratios express the relationship between the angle and the length of its sides. Okay. So now we are going to learn how do we calculate them. So let's take an example. Okay, one more thing we need to focus is the values of trigonometric ratios of angle do not vary with the lengths of the sides of the triangle if the angle remains the same. Okay. I hope that's understood. So let's say we take an example that is given is equal to tan A is equal to 4 by 3. Find the other trigonometric ratios of the angle A. So now let us take we have this angle, angle A, B, C, that is right angle at B, and this is angle A. So we are given that tan A is equal to 4 by 3. Tan A is equal to 4 by 3. Okay. So now we know that tan A is the adjacent side, sorry, is the angle side opposite to the angle, that is BC upon side that is adjacent to the angle, that is AB. So now here we are not given that the lengths of BC is equal to 4 and AB is equal to 3. This does not mean that they are of 4 centimeter or 4 units 4 and 3 units respectively. They could be in the multiples of 4 units and 3 units. So let us assume that BC is 4K and AB is 3K. So what we have assumed that they are in the multiples of K. So therefore the ratios are written as 4K and 3K. So BC is equal to 4K and the length of AB is 3K. So now we know that according to the Pythagoras theorem, AC square is equal to AB square plus BC square. So using the ratios, using the Pythagoras theorem, we can easily find the side AC so that we can find the other trigonometric ratios. So therefore, AC is equal to 4K square plus 3K square, that is 16K square plus 9K square. So therefore, AC is 5K. Okay. Now we need to calculate the other ratios. So firstly, we'll calculate sine of A. Sine of A is the side opposite to the angle, that is 4K upon the hypotenuse. So this is AC is our hypotenuse. In short, write it as hypo. 4K upon 5K. So we write it as KK gets cancelled out. So we get it as 4 by 5. Then we have cos A. Cos A is written as side adjacent to the angle upon the hypotenuse. Again, KK gets cancelled out. We get it. We write it as we get it 3 upon 5. Then now we can easily derive cosec A and cosec A, that is the reciprocal of sine A. So reciprocal of 4 by 5 is 5 by 4, and sec A is the reciprocal of cos A. So that can be written as 5 by 3. And now we need to find cot A. Cot A is can be directly written as the reciprocal of tan A. That is, tan A was given as 4 by 3. Okay. It was given as 4 by 3. So therefore, cot A is 3 by 4. So these are, so we have got our answer C. Here also the AC is hypotenuse is 5 by K. So we get sin A is equal to 4 by 5, cos A is 3 by 5, then cot A is 3 by 4, sin A is cosec A is 5 by 4, and sec A is 5 by 3. So this is how we solve the basic we calculate the lengths of sides or the angles using the basic trigonometric ratios. Okay. Moving further, you have exercise 8.1 that you need to do it on your own. That is the self-study part. Further, we have trigonometric ratios for some specific angles. So we have derived the trigonometric ratios for the angles 0 degree, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So yeah, so we have all of these sides are given in the textbook directly. You need to learn the trigonometric ratios. Okay, the derivation part, I'm not going to do it in the video. You can read it from the textbook. So the trigonometric values for these angles are for 0 degrees, sine A is equal to 0. So therefore, if sine 0 degrees is 0, sine 30 degrees is 1 by 2, sine 45 degrees 1 by root 2, sine 60 degrees root 3 by 2, and sine 90 degree is 1. Next, cos A, cos 0 degrees 1, cos 30 degrees root 3 by 2, cos 45 degree is 1 by 2, cos 60 degree 1 by root 2, cos 60 is 1 by 2, and cos 90 is 0. So now from this table, there are we have the values of the trigonometric ratios for we have six trigonometric ratios, but if you only learn one of them, we can derive the other trigonometric ratios very easily. And with practice, you will learn all the trigonometric ratio, the values of trigonometric ratios on your own. So how can we derive it is basically if we make a table 0, 30 degree, 45 degree, 60 degree, 90 degree. I'll write it on the notebook. If I say I have 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. I just have to learn the values for sine 30 for sine. Therefore, sine A. For sine 0, my value is 0. For sine 30 degree, my value is 1 by 2. My value is 1 by 2. Sine 45 degree, my value is 1 by root 2. For sine 60 degree, my value is root 3 by 2. And for sin 90 degrees is equal to 1. So now to get cos A, we just have to reverse all the values. So firstly, we have for sine 90, we have got 1. So cos 0, just write all of these values in the reverse order. Therefore, we get 1. Therefore, cos 0 is 1. Cos 30 is root 3 by 2. Cos 45 is same as of sine 45. Then cos 30, if cos 60 is 1 by 2 and cos 90 is 0. So now we have derived the cos values also. So therefore next up we have tan A. So we know that tan can be written as sine upon cos. So therefore doing sine upon cos over here we get sine upon cos. Tan A, that is sine tan 0, that is sine 0 upon cos 0. 0 upon 1 is 0. Then for tan 30, I have sine 30 upon cos 30, that is 1 by 2 upon root 3 by 2. So 2 in the denominator gets cancelled. So I get 1 by root 3. Then tan 45 is equal to 1 because sine 45 is 1 by root 2 and cos 45 is 1 by root 2. Dividing them, we get 1. Then tan 60 is root 3 and tan 90 is infinity because 1 upon 0. So anything upon 0 tends to infinity. Okay. Next up, I have cosec A. So cosec A is the reciprocal of sine A. So reciprocal of sine 0 is 0. Then reciprocal of 1 by 2 is 2. Okay, cosec A is not defined. Not defined. Then cosec 30 is 2. Cosec 45 is root 2. Cosec 60 is 2 by root 3. And cosec 90 is 1. Similarly, we can find out the values for sec A and cot A. Just go through this table many a times, then you could easily learn all the values from the given table. And therefore, we can use this table to find out the lengths of uh, or the sides of the triangles and what that has been asked in the question, depending on the question. So just refer the examples. You could easily understand the concept behind the trigonometric ratios, and you could easily calculate the lengths or the angles of the sides using these ratios. Next up, we have exercise 8.2. Again, that you have to do it on your own. Moving further, we have trigonometric identities. That is the last topic for this chapter. So there are three identities that we need to learn, and these identities are are universally accepted and that are true for all the conditions. So I'll just quickly write down all the identities. So our first identity is sine square A plus cos square A is equal to 1. So you can put any angle in the place of A, and you could you can prove this identity. If I take sine 45 degree, if I take sine 45, so sine A is equal, sorry, so sine, if I take angle A is equal to 45 degrees, sine 45 is 1 by root 2, and cos 45 is also 1 by root 2. Squaring them, I get sine square 45 as 1 by 2 and cos square 45 as 1 by 2. If I add both of them, my answer is equal to 1. So the identity is proved. So this is our first identity, that is sine square A plus cos square A is equal to 1. That is given over here also. The next identity is 1 plus tan square A is equal to sec square A. Okay, so okay. So next identity is 1 plus tan square A. 1 plus tan square A is equal to sec square A. Again, you can just put the values of angle. If I take angle A is equal to 45 degrees, so tan 45 degrees is equal to 1. So 1 plus 1 square is equal to 2. And you know that the value of sec 45 is sec square, and sorry, so I get sec square A is equal to root 2 and sec A is equal to root 2. So you know that the value of sec 45 is root 2. Okay, so hence this is also proved. Next up, the third and the last identity is cot square A plus 1 is equal to cosec square A. So you can take any angle that you know, and you know the trigonometric value for that angle, and you can just easily put the values in the angles and prove the identity. Okay. So yeah, this was the last topic of our chapter, that was introduction to trigonometry. This is a very interesting topic and concept that are we going to use. In the next video, we are going to learn some applications of trigonometry in real life. So go through the chapter once from the textbook, learn all the trigonometric ratios, their meanings, their values for specific angles, whatever are given in the textbook, and practice them well. Go through the identities as well, and practice all the solve examples. Go through the exercise questions as well. If you have any doubts, you can put it in the comment section. I would definitely clarify them. Thank you so much for watching this video. We'll meet in the next video. Thank you so much for watching. Have a good day. Take care.
वीडियोस बनाने हैं फिल्मोरा है ना।